So recording started, so it's streaming. So let's just confirm if it is properly streaming, and then we can begin. So recording started, so it's streaming. So let's okay. So it's record. Yes, people are confirmed also that it is happening. So let's begin. So we'll begin with a good definite integral question. So before, so it's at yes, recording stop. Yes. So the question will be correct. So am I audible? Okay, we'll begin now. Yes, I hope you can hear me. So let's solve the first question that we have for today. So this is not related to the topic of this week, but I encountered this problem. So you need to prove that this integral that you have is equal to minus pi by 2 to pi by 2 log of 1 plus b sine x by sine x dx. So I forgot to write dx, sorry, is equal to pi sine inverse b. So this is not a very simple problem. If you try, it's not directly integrable. This is quite a difficult problem. It's not directly, the solution did not come to my mind as well. So do you have any idea how we'll be going about solving this problem? Before we go on to methods of area and volume, let's warm up using this problem. So it's quite interesting. Anyone? So what would you try doing? Any ideas? Like you need not be correct, it's not possible. I got an idea after a few days regarding this. Okay, so I see no one responding. So am I audible first of all?
It is so-called improper integral.
Yes, it is an improper integral. So it's a type of an improper integral only, but due to definite, since it's definite, it's working out in some reason. So that's the good thing. So, directly, but it's not.
Sir.
Okay. Go ahead. Yeah, I can hear you.
A plus b minus x.
That is also not, that also did not work. That will, even substitution of normal substitution using log x and sin x is not working there. So let's start. So this is a type of question that you would generally, this is the last resort people take when solving an integral. So you see this integral is a function of x, right? So once you integrate it, this is a function of b. Are you agreeing to that? So this will become a function of b. Do you agree? Because x will be integrated out. Right? Do you agree? So this is I will be a function of b. Do you agree?
Yes, it will be.
Yes. So the trick behind solving this question is you take the derivative of I with respect to b. So do you know what happens when you take a derivative with respect to a parameter in the function which you are not integrating with respect to? So not partial, so directly it's a correct derivative, which is a complete derivative of I with respect to b. So this is, you are taking a respect to b. We have seen Newton-Leibniz, but you can't use Newton-Leibniz for here because you're taking derivative with respect to a parameter in the integral, and it is not dependent on the limits of the integral. So what happens when you do this? So since it does not depend on the variable of the integration, you can take the derivative inside, provided the function is differentiable and integrable. That it is proper correct function log 1 plus x. It's hopefully b is between 0 and 1, it is told. So its function is defined, differentiable and integrable. Hopefully, say let's consider differentiable only for the time being. So when you take the derivative within the integral, so it's a derivative with respect to the other parameter b, so it becomes a partial derivative, because the integral does not, the actual derivative does not depend on x, it only depends on b. So it becomes a partial derivative, log of 1 plus b sine x into sine x dx. So you can take the derivative of this function with respect to b. Now are you familiar? So what does partial derivative mean? Partial derivative means you treat all the other variables except that variable as constants, right? And differentiate with respect to b. So you differentiate with respect to b and treat all other variables as constant. Right? So what would be the derivative, partial derivative of the function? Someone?
One by 1 plus b sine x.
Correct. Sine x into 1 plus 1 b sine x into
1 by sine x.
So we have already
Oh, I see, that is given.
Yeah. So this is the derivative, right? So the next is you have to take the derivative of the function inside log by chain rule. So you will take the derivative of b. So it will be only sine x, right? This is ddb of 1 plus b sine x, right? Which is nothing but sine x. Agreed?
Yes, sir. Yes.
So everyone else agrees? I see no one else replying or they're not conversing today. So is it okay, or should we proceed, or this is the only step? After this it becomes a normal integral problem. Okay, so you are not asking, so that's I hope you understood. So this sin x and sin x will be cancelled, and you will be left with 1 plus b sin x dx. So this itself is a difficult integral problem if it is not, limits are not given to it. So if limits are not given, it is not integrable. So any idea of how to go about this? Now what Hedvi was pointing out, you can use that, right? Could you use that? Why would I go about using it? You see, if she told me that integral of fx dx from a to b dx is f of a plus b minus x dx from a to b. We have already shown this in the definite integration classes that we have had, or the tutorial sessions that we have had. And so you can write this as 2 times I, or 2 times di db as the integral of minus pi by 2 to pi by 2 dx 1 plus b sin x dx, or 1 by minus of 1 by, or rather 1 plus 1 minus b sine x. Agreed? How I did this? How I got this second function? So this is also this integral of 1 minus b sine x dx minus pi by 2 to pi by 2 is equal to integral of dx 1 plus b sine x minus pi by 2 to pi by 2. Do you agree? Because what I have done, this minus can be written as pi by 2 plus pi by 2 minus x, which is b of sine minus x. Understood? Any doubt? So I added these two together. Right? I hope it is clear. So if we add these two, you will have in the denominator. So in the numerator you will be having 2, right? And in the denominator you will be having 1 minus b square sine square x dx. Agreed? Or I can cancel 2. Yes or no?
Yes.
Yes, okay. So others? Is it okay?
Yes, sir.
Okay. So but you understood all the steps. The derivative I right? You did understand why I took the derivative. So normally it's a non-integrable form. You have a log that shorts, and you had a denominator of sine x, and you could remove sine x if you took a derivative, because this sine x would be cancelled. This is the motivation behind using the derivative trick, right? To bring an easier integral. So now this integral should be familiar to you. What should I do with this integral? This is a very standard integral. We have been discussing this integral at length. Any idea? So this itself is a good question, not a very difficult question, but a good question to ask. How do I solve this integral? So whenever you have trigonometric squared functions, you try to, especially sine square x's and so on, you try to bring tan x and sec x.
Divide by cos square x, sir.
Exactly. Divide and multiply by cos square x, or multiply and divide by sec square x. I will do the later sec square x if I multiply, and if I divide by sec square x, what would this equation be? So I gave you the hint. Mr. Pandey understood. So this would become sec square x dx. So you will have sec square x minus b square tan square x, right? This be your function, right? And then you could you remember, right? 1 plus tan square x is sec square x. So I will just replace sec square x in the denominator by tan square x. Very useful substitution to do. Minus pi by 2 to pi by 2. So d of tan x in the numerator, and the denominator will become 1 plus tan square x. So you will have 1 plus tan square x is 1 minus b square tan square x, right? This will become your integral. So why I wrote the numerator as d of tan x? D of tan x is, the differential is sec square x dx, right? Agreed? Or if you are not
Yes, I agree.
yeah, so tan x you can take as t for the time being. So if you take tan x as t, so dt by 1 minus b square by into t square or I will just skip one step and write it this way: 1 by 1 minus b square 1 by b squared from minus infinity to infinity. Why is it minus infinity to infinity? See, t and tan x, right? So if tan x is at whatever, let's take x is equal to minus pi by 2, so you have tan t is equal to tan of minus pi by 2, which is minus infinity, and pi by 2 is tan of pi by 2 is tends to infinity, right? This would be your integral. Very clear. So you have plus t square. So since it's an even function, so you can just take a 0 to infinity and 2 multiplied, right? Agreed?
Yes, I agree.
So now, yeah, ahead we go ahead. You have a question?
No, sir, I missed it.
Yeah. So next, what would be the what is the integral of a square plus a dx by a square plus x square? I have it written, but I want to test if you are practicing.
1 by a tan inverse x by a.
Correct. So a is here. What is a here? Your a here. This is your a. So it is 1 by b square tan inverse t by 1 minus b squares root over, right? This is why b is given between 0 and 1. You understand now, right? Or minus or mod b is given less than 1, because the integral is not valid otherwise. It's not integrable, right? This is why mod b is between 0 and 1. So now what is it? If I cancel this, you get 2 by root over of 1 minus b square, and you have, what is the integral? What does the integral become? Tan inverse infinity minus 0, right? So this is pi by 2. So you get pi by root 1 minus b square. Agreed?
Yes, sir.
Now what will I do? Now throughout the integral, so you understood. So we have got a very nice form. So a very difficult integral has been converted to a very simple integral. So now Hedvi, how will I get if you have not responded, so you could respond, how will I get the value of I? If you could. So what is the
We will integrate.
Okay.
Remove db right and
Correct. So you will do variable separation form. So this is nothing, just move db to the right hand side and integrate. Very intuitive. Intuitive things you can do with in the first order integral. So you multiply db on both sides and take the integral. So here we are not going to take a definite integral, but we will be taking an indefinite integral. Why, we will be see. So if I take an indefinite integral, what will this be? What is root over of integral of root over 1 minus x square? We have done it several times, derived it.
pi sin b.
Sin b or sin inverse b?
Sin inverse b.
So sin inverse b is
Plus c.
Yes. So this is your integral. So we have got a very good, nice family of equations. So it's true for all values of c now. But is it actually true for all values of c? How do I find the value of c? Any idea? So I'll show you the equation once again. How do I find the value of c? So I have found I as a function of, so IB has been found to be pi sin inverse b plus a constant. So how do I find? For my case, I need to prove that c is 0, right? How do you think we will prove it? See, this I, as I told you in the beginning, what is it a function of? It's a function of b, right? So you put the integral b equal to 0, right? Mod b is said to be less than 1. So if I put b equal to 0, what will the integral turn out to be? Log 1 plus 0, which is 0, right? That is 0. You agree? You see IB is 0, I of 0 is 0.
Yes, sir.
So b, this sin x will become 0, and you will have left the integral of 0 is 0. You don't, if you integrate anything that is 0, you do dx times 0, it's still 0. It's nothing to integrate. I hope it is clear. So you put the value of b here, so you will get I of 0 is equal to pi sine inverse 0 plus c, which is 0 equal to 0 plus c equal to 0, right? So we have shown c equal to 0, so I of b is equal to pi sine inverse b. I hope you found this insightful. We have used 3 different approaches. One, indefinite integral method, where you multiply sec square x whenever you have squared of sines or cosines. A plus b is equal to thank you, Mr. Pandey. So it's this. So next is we have used a plus b minus x, another property of definite integral, and one more property is whenever you have integrals, if you can write integrals as a function of more than one variable, where you are integrating one variable where the other variable remains a parameter, you can make the integral a function of that parameter. That's a method, or that's a approach that I showed you. That whenever you have a parameter in an integral, you can make the integral a function of that parameter, right? Because x will be integrated out, or whatever the value of whatever you have in dx will be integrated out, but the parameter will remain when you integrate it out. So you can take derivatives and do manipulations. It becomes easier because you can take partial derivatives. You need not take derivative with respect to x. Because x is being integrated, you just need to take derivative with respect to the parameters inside the integral. That's the idea. So next is we would be solving questions on areas. So the idea is areas, what we'll do is we'll be doing 3 methods that was discussed in the discussed this week in the session, and we will be solving questions related to those methods. So the 3 methods would be slicing, washers, and the disk method. So they're very simple methods. I'll give you quick pictorial description of those methods, and we'll be just practicing integrations basically. So the first, or the slicing method, what does it say? So for example, you see that, look at this figure, right? So if you have an area like this, if you know area as a function of x, right? So what can you do? You can just, you are told to find volumes, right? So if you are told to find volumes, what have we been doing in areas? In areas, what did we do? We did an integral by chopping dx into f of x, right? This was given, area was given by this, agreed? But for volumes, what will I do? I can make small cuboids, right? Or small volumes, infinitesimal volumes, if I know the area as a function of x. Do you agree? If I want the volume between A and B for this solid, what will I do? And if I am given A of x, so you see, I will, if I know this area, what is this volume that I am drawing? Right, this is your volume. So this is d of x, and this is area of x. What is the volume, or what is your differential volume? dv of x. To draw it clearly, I'm drawing it here. So this is a of x, and this is dx. So do you agree this is ax dx? That's what I've written here, right? And then you can integrate. You can, whenever you want to remove partial, what you do is you integrate it out, right? You take the sum or you integrate it, right? So V turns out to be the area integral of ax dx if you are given the volume. So let's do it for this question. Very simple question just to introduce the topic. So given the surface area is a log of x, what is the volume of the enclosed solid between x equal to 3 and 4? So the surface, the volume would be, as we have discussed, so you are told to find volume of a solid where ax is equal to log x between x equal to 3 and 4. So how will I make the integral? What will I to make this integral into? So volume would be ax
Integral 3 to 4 ln x into dx.
correct, log x dx from 3 to 4. So what is log x? We have discussed. We will do integration by parts. Integrate this, so you will have lx log x, and differentiate this, so you will have minus integral of x into 1 over x dx. So this is what you have differentiated. So I should write the other way, and this is again you integrate. So right, you the second function in partial we have discussed last week. So the first, you keep the same function intact, and this integration is just multiplied. In the second, you take the integral of the product of the derivative of the first function of the differentiable function and the integral of the integrable function, or whichever you want to integrate. So you left out with log x minus x from 3 to 4, right? So this is 4 times log 4 minus 4 minus 3 times log 3 minus 3 or plus 3. Agreed? So this is your 4 to the power 4. It's 256, right? 256. 2 to the power 4. 2 to the power. So 2 to the power 2. 4 to the power 4 is 2 to the power 8. Correct. 256 by 27 minus 1. Understood? So this is your volume that you will get. This was just a warm up. Now the next two things, I hope this is clear. So next two things would be finding the disk method and the washer method. So primarily we'll be dealing with volumes formed by rotations. Generally, you will not be given areas. You will be told to visualize what happens when areas like 1D figures or functions are rotated about an axis. So take this for example. So what is it? So if you have a function like this, agreed? Remember, we will consider only f of x greater than 0. Disk, comma, washer method. So if you rotate it about x-axis in 3D, x-axis becomes your axis of rotation. So you're rotating it in 3D. You're having this is coming out this way, right? This is what is happening. So you understand that you will have a volume like this. Agreed? Do you agree to this? So you will have a cross section of a circle. Do you agree? Because you are taking the entire function rotating about an x-axis. So your distance from the this axis of rotation is fixed. So whatever you have, x comma y would be a circle, or here in our case it is, say this is x, or x, this is y, and this is z. So this circle is in the xz plane, so you will have x square plus z square is equal to b square. Do you agree? If you rotate, This about the x-axis,
Yes,
or here you have
we
written
are,
the y-axis.
in
Correct.
fact, we are creating millions of disks of infinite small.
Yeah, infinite small disks. Correct.
Yes.
So we last method we did slicing. So in this slicing we would just be slicing, but we will also be calculating the cross-sectional area on the fly. So we do not need the cross-sectional area to be given to us because we are circles, right? So this will be your cross-sectional area, A as a function of x, would be pi times fx, right? So this is nothing but B is nothing but f of x. Do you agree? So this is your cross-sectional area. The radius is the value of the function at x. And what is your dv? dv is ax dx, or v is integral of pi f of x squared dx. Similarly, in the washer method, what happens is you have another surface. In washer, you do not have anything in between, you have something outside, right? It will taps and all. So you would typically want this volume. So this is like finding area of two concurrent circles, right? So if you see the cross section, I have all this written in my notes, so I don't need to like. So I'm just writing it in the same. So this is your f1x. This is f2x. So what is your dA?
It will be something like capital R square minus small r square.
Correct. So dA is pi of capital R square. This is capital R. This is small r. And this is yours. Elementary mathematics is giving you this, which is nothing but pi of f2 square, whatever you've written, f2 square x minus f1 squared x. So your this is your area. So your volume would be integral of area times dx. So area dx dv, let's write it this way, pi f2 square minus f1 squared dx from a to b. Agreed? So this is your volume. So now we'll be solving questions throughout this remaining 1 hour or 1.5 hour, quarter hour. These questions related to the washer method and the disk method. So before we begin, I'll be waiting for 1 minute, and if anyone has a doubt, you can ask. Otherwise, we'll be going over to solving say 9 questions related to these problems. So I'll be waiting for 1-2 seconds, a few seconds. Okay, so no doubts. So let us solve an easy question first. Let us solve something algebraic first, and then we'll go into geometric stuff. So these two are easy questions. Let's solve these two first. So I'll just copy these two, and then Mr. Pandey, we can see how to plot them and see. Let's solve them by algebraic methods instead of visualizing right away. Let us visualize, not a problem, but just do it by hand. So it said that f of x is greater than 0 is rotated about the x-axis. And then this is your assignment question, assignment 11 question. So then the volume always turns out to be b square minus ab for all values of b, right? So it's a parameterized over b. So what is your how can you write the, so you're told to find fx. How can you write the integral that will help you to find it? Any idea? So how do I set up? So I have to write an integral or v of this function f to be b square minus ab. Any idea how will I do that? Yeah, go ahead.
Sir, integral f of x from a to b
Correct.
into dx.
Integral of this, not f of x, right? A of x. So your d or your area as a function of a is pi times fx squared, right? This is your area. We have seen just now. You followed, right?
Yes, sir.
This is your area, so you take multiply area times dx. So your v is ax dx from a to b. So a to b, as you said. So vf is a function of b. Do you agree? Because b is rotated, b is changed, right? So you are told this is equal to b square minus ab. How will I do this? Next, what will I do? So what should I do next to find f of x? This is what we have been discussing last couple of weeks.
Sir, b is equal to x. Then Leibniz rule.
Correct. No b equal to x. Yeah, you are saying use the fundamental theorem of calculus or the Newton-Leibniz theorem. So you just take.
Yes, sir, exactly.
You take the derivative of v with respect to b, right? So you'll be having pi f of b squared into db, right? Newton-Leibniz minus same thing, pi of f of a squared into dA dB, which is 0. It's a constant, which is equal to 2b minus a. Agreed? I took the derivative with differentiating both sides. Understood? I differentiated throughout these three equations with respect to b. So now you will be left with dB, it is 1, f of b squared is equal to 2b minus a by pi. So f of b is root over of 2b minus a by pi plus minus of it. So b is just a dummy, you can replace it with x. So assign x is equal to b, or the other way, plus minus 2x minus a, right? Agreed? Is there any doubt? I hope Mr.
No, sir, it's okay.
Yeah. So now next question is rotating 1 plus cos x about the x-axis. So this is also a very simple question, just a warm up. Again, so 0 to pi by 2 pi into 1 plus cos x dx squared is your volume. You agree? So let us visualize this. What will it look like? So cos 1 plus cos x will be 2 to 1. Agreed? This is your 1 plus cos x between 0 and pi by 2. And you are rotating this so you will have something like this. This is your volume. There will be no emptiness, but it will just be this, like a dome. Agreed? See, Mr. Pandey, you had wrote to me regarding visualizing, right? So this one we did it without even using a graphical calculator. I'll be doing it anyways after some time, But is it useful, insightful to see how to do it by hand when you are not able to get them? So you'll not be getting them in exams. Try to plot f of x and then rotate it about your axis of interest. Understood? Mr. Pandey, you had made a mail to me.
Yes, sir.
Yeah. So let's see the volume. So we'll be going and visualizing the next volume in the thing. So this also we can do then. We'll do a couple of them and then you can do it on your own, the rest of it. I'll do 3 of them actually. So 1 plus 2 cos x plus cos square x dx, which is pi. 0 to pi by 2 is 1 integral is pi by 2. 2 times cos x dx, 0 to pi by 2, plus how to integrate cos square x? 1 plus cos square x between 0 to pi by 2.
1 plus cos 2x by 2.
1.
Yeah, both of you are correct. So 1 plus cos 2x is cos square x 2x by 2. So dx. So you see this integral cos 2x, integral of cos 2x between 0 to pi by 2 dx is 0, right? Because cos 2x will have a complete period between 0 to pi by 2. But not a complete period, half period, which is what to say, odd about pi by 2. Agreed? So this is actually pi by 4 and this will be pi by 2 because you will be multiplying 2, so pi by 2 will become pi by pi. This is graph is cos 2x, right?
But sir, there will be outside will be 4.
4 where? So but you will be having 0, right? Cos the integral. This is an odd function.
Now on the third integration here.
That you will have. We will do. I just talking about this integral. This. If I separate cos 2x by 2 and half outside separately, I'm talking this cos 2x will become 0. I'm not writing it at 2 different integrals. So this is what? This is integral of half dx plus cos of 2x by 2 dx, right?
Yes. Yeah.
So this one will become 0. This is what I meant. So this is turning out to be pi by 2. So this is pi by 2 plus cos x is integral is sin x, right? Sin x between 0 to pi by 2 is 1. Agreed? So 1 minus 0 is 1. 1 into 2. This integral is 1. And the second integral is plus pi by 2 into half. Is this okay? So it is 2 plus pi by 2 plus pi by 4 into pi. This is pi into 2 plus 4, 3 pi by 2, right? No doubts, I guess. Is this all right?
Okay. It's okay.
Yeah. So I hope this is fine. So let us go. There's not the calculations also you can try out. So this is primarily to see how to form the integrals. Next we'll be doing this. So I'll be sharing my laptop screen also, and then we'll be seeing how to visualize this. Let's first, what we'll do is we'll solve this question number 5, and then we'll be visualizing. So we'll be seeing how good is our drawing. Number 5. So let's do it here itself. It's a easy problem. So 3, 4 and 5. So we're doing in number 5 now. So we are saying the volume by rotating the lines. Y is equal to x, y is equal to, this is x, this is x by 3 between 0 and 4. So do you agree you will get some volume like this? Very difficult to draw by hand, but still we'll be trying. And this will grow. Yes, we have forgotten washer and discs now. We all now know only what is it? Only disc method, because we'll be using washer is actually a disc, right? So my artistry you'll have to pardon, not that good. It's better to draw on board, but I'm trying my best to what I can do on this paper. Are you able to visualize it? How will this look?
Yes, sir, perfectly okay.
Correct. So now, how will I integrate? How will I do this? Now somebody who have not. So what did we say? So area of cross section would be two concurrent concentric circles. So outer circle is x, inner circle is x by 3, right? Radius. So what will I do? So the volume would be pi times. So what is your d? What is your area? This is your area, right? This is pi times x square minus x square by 9. Do you agree?
Yes, sir.
Into dx. So this is your area a of x dx from 0 to 4. So we'll see. This is the integral will turn out to be so it's very simple, x cube x square by 9, 8x square by 9 into pi 0 to 4 dx, or it is 8x to the power 3 by 27, or 8 pi x cube by 27 from 0 to 4. So you have something like 2 to the power 2's whole cube into 2 to the power 3 into pi by 27, which is 2 to the power 6 to the power 9, right? 2 to the power 9 pi by 27, or 3 to the power 3. Okay, or 512 pi by 27. Okay, I hope the calculation is alright. Yes, it is. I think it's alright. X cube, so 4 is x to the power 6, x to the power 6 into x to the power 3 is x to the power 9, and divided by 3 into 9 is 27. So this is what you have when you have two different lines and you're told to find this, or two different functions and you're told to find the volume in between them. This is a simple example. So we're halfway there. So let's see using a software. Let's stop sharing from here. And I'll share this screen. So GeoGebra 3D calculator. So are you able to see my screen? Because I can't see you while I'm sharing this. Now, can you confirm?
No, sir.
You can't see my screen. Okay, now you are able
Yes,
to.
sir.
Okay. So you're able to now. So let us see. First, let us take y or something like this. So let us take f of
Sir,
a.
it is not visible to me, your screen.
I think it's visible to me. It's visible. You just try to refresh.
Okay, sir, I will try.
Can you leave the call and rejoin? So f of x is 1 plus cos x. Yeah, can you see it now?
Yes, sir, it is visible.
So x between, this is how you write. I showed you Desmos. This is how you write in GeoGebra. It's just figuring things out. Pi by 2, right? This is the first function, and then you can use tools. There is something called, so you don't need to write any code. Generally you need write a MATLAB code to see this, the surface. So if you do a surface and just click on this, you will get a surface, but volumes you will not get. You can visualize the volume when you, so you can write a function like surface your function 360 degree about the axis you want to rotate. You see, do you see the how 1 plus, as I had drawn in my by hand, it's exactly that. Do you understand, Mr. Pandey, how to use this software?
Yes, sir.
Okay. So volumes, there is not an option, but a surface you can see and you can imaginarily fill that surface. So let's do it for another one. So the line, right? So f of x would be x for between 0 and 4, right? So you can rotate this and see. So x between 0 and 4, it's all right. G of x is equal to x by 3 between 0 and 4. Agreed? Next, what will I do? Surface, as I had shown you, f 360 degree, x axis. I don't know what is happening. Just now I had seen this. I think it's having some rendering problem. Don't know what is happening. 360 degree I rotated about the x axis. Here f of x. Let's delete it again. Surface function and this, so f comma 360. So I think this is having a it's some multiplying by something. Now it's okay. It was a rendering. $359. So there is some problem with the software. I have always seen. I don't know why. You have.
Can you try instead of 360 putting 2 pi?
It's not a 2 pi, but 360 was working. Let's see. I will try. These people don't understand. Yeah, it's working. I don't know. Maybe some options are changed. Thank you. So next will be B, is surface of say your g comma 2 pi comma x-axis so you see the figure that I have drawn was actually correct, right? So if you fill the solid between these two surfaces, you will get that what we had written, right? Right, you understand, right? I can go to the next question if you yeah. So I hope you can use these now, and I hope it was useful, Mr. Pandey.
Yes, sir. Thank you.
So okay, let me share my tablet now. We will do one more interesting plot, but that we'll do it. That's at the end. So let's wait for the. We'll do it at the end when we have solved everything. Then we'll do it. So 5 also done. So next is some more involved question. So we see that it is rotated about the y-axis. Find the volume by rotating y squared. X is equal to y squared minus 6y plus 10 about the y-axis. How do I do this? Let's see. First of all, try to plot as we have always been doing in calculus f of x. So to plot f of x, what will I do here? What is my steps for plotting f of x? Okay, so let me see what we'll do. So x, you try to make a perfect square, then you will have an equation of a y square equal to 4ax, like a parabola, rightward facing parabola, right? So if you complete the squares, you have y minus 3 squared plus 1. Agreed? Y squared minus 6x plus 9 plus 1. So you have x minus 1 is equal to y minus 3 squared. X minus 1 squared. So this is very familiar equation, right? Y is equal to 4ax. So a is half 1 by 4 here. So can you tell me what will this equation be? I have already told you translation of graph, how to plot graphs. How will it look? So where will it be centered? Where will the parabola centered? So x minus a, this is the center, right? 1 comma 3. When you shift your origin, that becomes the center. So your x is 1, y is 3. 1 comma 3 becomes your center. And then you have your parabola, right? Are you okay with it? At x is equal to 5, your y value is plus minus 5 minus 1, 3. So 3 plus minus 2. So 1 comma 5. At 5 you can have values between 1 and 5. Why am I finding this? Are you understanding? What am I doing?
Yes, sir.
So this is your plot. Now what will I do? I will rotate it, right? It's told rotated about the y-axis. So this would become your volume. Try to visualize how will it look. It will look like a flask. something like this, right? Inside is hollow, and you have weight on the outside. Agreed? Opposite to a normal flux, you have the weight on the outside. Are you able to visualize?
Yes, sir.
Good. So what will be the, how will I set up the integral? Since you understood, you will only tell me. What would be the integral? About axis y we are doing this. So about y if I do, so I will see I have also found x as a function of y, right? Y is not a function of x, but x is a function of y, right? So if I just write this plus 1, so your volume can be written as, tell me.
Y minus 3 whole square plus
This
1.
is your outer radius, right? Which is 5.
So 5 square minus
5 square.
y minus 3 whole square plus 1 whole square.
Correct. So do everyone agree with what she says? And this will be ranging between 3 and 5 into
Yes,
2.
sir. Yeah.
Right? Because it is symmetric about 3. About 3 this is symmetric, 1, 2, 3, and this is 2, this is also 2. Always try to bring in symmetries, it will become very easy. No need to integrate everything. So 3 to 5 if you integrate, or even 1 to 3, it's simpler, right? 1 to 3 if you integrate, enough. So this turns out to be 2 times pi integral of 1 to 3 25 minus y minus 3 whole to the power 4 minus 2 into y minus 3 squared plus minus 1 dx. Quickly integrate this. So if we quickly integrate this, you will have 24 into 2. Agreed? How I skipped the step. So this is to 24, and then if I integrate, I'll get x. Integral of 24 dx is equal to 24x from 1 to 3, which is into 2. It's a linear function, just multiply by 2. Minus y minus 3 whole to the power 5 by 5 minus 2 into y minus 3 whole to the power 3 by 3. Agreed? Is equal to 22 pi 48 minus, your denominator will become, so this is between 1 and 3. So you see the value of the function is not defined at, it's 0 at 3, so you need to consider 3. So you'll be only left with positive values. Agreed? Just I'm flipping this limits. If I flip the limits, negative becomes positive. Do I agree? Flipped limits. If I flip the limits, negative becomes positive by fundamental law of calculus. I have shown that already. F of x dx a to b is f of b minus f of a. So if we put a minus here, this is essentially writing f of a minus f of b, f of b minus f of, yeah. So and this is nothing but saying b to a f of x dx. So directly solve the definite integral by, but why is that allowed in your exams? I don't think. I don't want to solve it using Desmos. I want to do it by hand. So this is 2 to the power 5. Again 1 minus is a negative powers, 1 minus 2 to the power 5 will be negative 2 to the power 5 by 5 minus 2 into 2 to the power 3 by 3, right? So 2 pi 48 minus 15. So you have 3 10 to 2 to the power 5 plus 10 into 2 to the power 3, 2 to the power 4, which is 2 pi 48 minus 2 to the power 4 into 3 into 2 6 plus 11 by 15. This is your answer. So you can solve it using Desmos and check. Even if there is a problem, this is not a problem at all, because this is just calculations. So I hope I did everything correctly. All the steps were correct. So next what we'll do is, this question we have done. Next is the 7th one, which is saying consider y equal to 3x to the power 4 obtained by rotating between and the lines between y equal to 3. This is a bit involved. This is your assignment question, number 2 question, and I to pick the most difficult of your assignment question. Maybe I don't know it's similar or not. It's similar to one of your questions, I believe. So I hope there is no doubt with the last question, right? I'll wait for a couple of minutes and then yeah. So what I'll do is, let's start with this. So this function looks like, so we always, as I told you, try to plot the function. Number 7 is a very simple function, right? Just like a quadratic, like this. So let's say this is minus 1 and 1, right? This is what your function looks like, and you are saying that you are rotating it about, you're rotating all of these, so you're essentially rotating this volume, this area into a volume. This part is understandable, right? I hope it is understandable. You're essentially rotating this, since you're rotating 1 and everything like this, so you're essentially rotating this way. Next, what will I do? Between minus 1 and 1, about y equal to 3. So what is the value of y is equal to at x is equal to 1? 3 into 1 to the power 4, which is 3. Right? So this makes the problem simpler. Why? We'll see. So if you can see, this is your y is equal to 3 line, right? So if you reflect this about this line, you will get something like this. And you'll be told to find this volume. And if you visualize it, how does it look? I'm trying to be as artistic as possible on a tab. It will be a cylinder, because you're rotating. And you will have a sort of an egg inside it. And this will be your volume. Right? This is sort of, try to visualize in your heads, and you'll be able to agree with me. So now that is just visualization. Even if you cannot visualize, the maths does not have a problem with. See, so now what is the trick that you will be using? So you can reflect about y equal to 3 and try the question, but there is a very simpler way. Instead of rotating this about y equal to 3, can I rotate this about y equal to 3 and make this the x-axis? If I make this the x-axis, this is minus 1, this is 1, right? So what would this equation turn out to be? If I relabel y equal to 3 as x-axis, and I want to write only the equation of the top parabola. What will it be? If you have understood, tell me what will it be? I'll give you a moment. So this was your y equal to 3x to the power 4. What would this be if this is the, so I'm forget about the top curve, look at this curve. What would this be? Given that this is reflected about y equal to 3 this way, what will it be? This is what? This is minus 3. If you center it about 3, this point, this is minus 3. I don't understand what is the problem. See,
It is shifting of the axis, right?
correct. This is two-step thing. So if this is your one function, right? This is minus 3x to the power 4, and you are told this. So if I shift this upwards 3 steps, minus 1 to 1, so this is nothing but 3 minus 3x x to the power 4. Do you agree? Just shifting f of x plus a c, a constant that you are adding to shift the curve upwards. I hope it is clear. So you have a doubt, any one of you?
No, sir. Clear.
Correct. So that's good. So let us see what would be the area in that case be, or the volume be. What would be the volume?
Sir, pi of 9 minus 3x raised to 4 whole
Do
square.
so. Yes. 3 minus 3x to the power 4, this one whole square, right? This is your function, this is your 3. And this is 3 minus x is 3x, right? So this is r1 square minus r2 square, agreed?
Yes, sir.
Between 0 and 1 into 2. You agree with the limits?
Yes, sir.
So this is very simple now. What will you be left with? 0 to 1 pi 9 minus 9 plus 9x to the power 8. Sorry about that. 9x to the power 8 is negative. Minus becomes plus 12. Is it 12 or 18? 18. Or you can do something. Why am I doing this? Shit. Sorry. So you can just 3x square you can take common, right? If I take 3x square common, so you'll get 1 1 1. Agreed? I took 3 was there inside this bracket. I took 3 outside, it became 3x square, and here there was 3x square. I took all of those common and made it 18. So 1 minus x to the power 4 squared dx. So this is 0 to 1, 1 minus 1 minus plus 2x to the power 4 minus x to the power 8 into 18, right? So this cancels, so you are left with 2 by 5 minus 1 by 9. So 18 pi 45 and then you have 918 18 minus is 5 is 13. 2, 5. 26 pi by 5. Right? This is your answer. Do you understand?
Yes, sir.
Okay. So I hope this method was clear. So next what we do is, this is one of my the figures that it will form is one of my favorite of today's session, but let's see. So 8 and 9 we'll do together and then try and solve the figure of one of these. So number 8 is again a simpler question. So how does so first step would be plotting the curves. So 6, it would start from 6. So I'm plotting this y equal to 6 e to the power minus, and this is, say, some point. This is 1, this is 0. This starts from 6, right? There's a decay exponential. Y is equal to 6 e to the power minus 2x. And the second equation, what will it be? See, y, you complete the squares, you will be able to understand. 6 plus 4x minus 2x squared. If I take 2 common, I'll get 3 plus 2x minus x squared. I take a negative common as well. I'll get negative here, and positive here. So I get minus 2x squared minus 2x, and you have, what to say, 3, right? So I'll make it 4, or what will I make it? 1. And what will I have to add to it to make this 1? So let's write it this way. Forget this. So if I write it as 2x squared, negative of 2x squared, minus of 4x, minus of 2. So I'll be left with 4, right? This becomes 4 minus 2 into x minus 1 squared. Do you agree? Or no? Is it right?
Right. Yes, sir, it's correct.
Okay. 6, yes. But at 0 it's not matching, no? Oh, minus 2 I wrote, no? This is to be plus 2. Sorry. So minus 2, this has to be 8. Right? This is correct. The previous one was not correct because I wrote minus 2, so a squared would not form. So,
Right, sir, right.
so you take 2 out, 1 here. So it will be x minus 1 squared. So now you see, you put x is equal to 0, it's on the same point, right? 6. And it's a parabola with x is equal to 1 as its maxima. Do you agree? Because x is equal to 1, y is equal to 8, and y is always less than equal to 8 because this is positive, right? Something like this. This is what your graph will look like. I hope it is clear. This is faster decay, but anyways, the morale is sort of clear. So you will have something like this as your this will be a sort of a frisbee you will be having, right? Are you able to visualize? When you rotate it about the x-axis, this is where your volume will be. I hope it is clear, right? Everybody who are quiet, is it clear to you?
Yes, sir.
Okay. So what would be the volume here in this case? The volume would be number 8. So once you have written it down, the volume is a simple 1 second work. So it is integral of pi of from 0 to 1 6 e to the power minus 2 whole squared minus, or rather this is lesser, right? So this is 6 e to the power minus 2x squared and 6 plus, or I'll write 8 minus 2 x minus 1 squared. This integral is over dx. Let's do it quickly. So what is it? Pi between 0 and 1, 8 dx minus integral of, oh I put the square, forgot to put the square here. So it is 64 minus 4, 16 times 32 x minus 1 square, then 4 x minus 1 to the power 4. So just put the integrals straight away, right? Minus 36 e to the power 4 dx, right? Do some fast integration. So what will you get? 64 minus 32 x to the power minus by 3 between 0 and 1. So 1 is useless, so just put 0 at x is equal to 0, and this will become plus, and this will become 4x to the power minus 1 to the power 5 by 5, again at x is equal to 0. So this turns out to be a negative. So just changing the sign and putting x equal to 0, just as we did in the last equation. And the second one, this one will become where is it? Okay, so become 36 x to the power minus 4. So you will have integral over this. So if I make 4 here, 4x, so I'll be left with 9 here, and this will become a positive. So I'll get 9 e to the power minus 4x between 0 and 1. So this is 0 and 1. So this is minus. So you will have, correct, 0 and 1. So you will be left with 9 e to the power minus 4 minus 1. And you can put these values, you will get pi 64, 32, 32 by 3 minus plus 4 by 5 minus 9 minus e to the power minus 4. This is your, so this is not that important a thing to consider, so but you will still get this as your equation. Let me just check, just answer once. So I remember something else that I have got. Oh, I think we did. Okay, this is about the x-axis, so it becomes simple. Anyways, I had solved a more complicated version of it. Now I had done it about x equal to -2. So you can try it about y equal to -2 and see how will you go about doing this. Okay. So there's a homework question, y equal to -2. Also you can reflect and see, and then it will give you some idea how to again recenter stuff, right? So you understood this question all right, is it? Are we good to proceed?
Yes, sir.
Others?
Yes, sir.
So I hope it is clear now. Last before we go on to a new concept, so this figure I have drawn here, I'll do it on the app once, but before let's complete all the questions first, and then last it will be a fun exercise. So volume formed by rotating the area y is equal to 4 minus x square and y about the x-axis, right? So your question says your y is 4 minus x square and y is equal to 1. Do you agree that this is your so I should not draw it like a parabola? You agree to this? So this is y square plus x square is equal to 4, and only for y greater than 0, right? This is the equation of your circle, and y equal to 1. This is y is equal to 1. Agreed? So this you are rotating, so you will have something like, again similar to a question that we have already done, but the integral is going to give you an idea of something. So anyways, it's a simpler question actually. So this will be something like this. If you rotate it, you will get a sphere, right? If you rotate the top one, you will get this one will be a sphere, and you will get a cylinder if you rotate a straight line. Are you able to visualize what I'm saying? So this is a part of a circle. If you rotate a semicircle, you will get a sphere. The volume inside it will be a sphere's volume. So what would be your area of this volume of this area? dV will be A times dx, which is pi times, this is 1, or what is it, 2. Oh, we are sorry, we'll be rotating it about y is equal to 1. So y is equal to 1. Let us see which one of it is y is equal to 1.
Sir, y will be below.
So hello,
Y is equal to 4. Y will be below.
Yeah, I'll do it. You're not audible. Are you? Everyone can hear you. So okay, can you be a bit louder? 1 second.
Sir, y will be the below.
Y will be below, right?
Yes, sir. Of the apex.
Just a second.
At the apex, the coordinates will be 0 and 4.
That I understand. 0 and 4.
And the straight line is y is equal to 1. That will be below 0 and 4.
That's what I will do. Anyways, you're saying this, na? This is your y.
Yes, sir. Yes, sir.
That's what I'm saying. And rotating this about the x-axis. So I did not read the question properly. Not y is equal to 4. Sorry. I had forgotten. I had seen the equation wrongly. So you are rotating. Sorry. So what are you rotating? You are rotating y. This is y is equal to 1. This is at 4, right? This is at y, x square plus y square is equal to 4 is the equation of the circle. So you'll get something like this. Agreed? from 0 to 1, and you will be getting, what will be your volume look like? What will your volume look like? Something like this, right? So it's like a ellipsoid, not exactly an ellipsoid, but a feel like this, right? So only you will have mass in these parts. You agree? Like a capsule. So what will be your area or your volume dA? It will be 4 minus x squared whole square minus 1 squared between x is equal to 0 and 1 into 2. Do you agree?
So here the axis of rotation is y equal to 1, right?
No, x axis. Y equal to 1, these two you are rotating. You are rotating, I had seen the question incorrectly. So you are rotating y root over f x minus 4 minus x square and y equal to 1 about x axis.
Okay.
Understood, right? So, okay. So this is 2 pi.
Sir, limit will be 0 to 2, I think.
I have, sorry again. So I'm again confusing it with 1 minus x square. Sorry. So this is, no. Sorry. 0 to 2, no. We'll solve it and see what will be the limits. Whatever is the limits, we'll be putting 2i2 into that. See, y is equal to 1, right? Is this equation, agreed? Of this line. So what will be this? You can solve it in many ways, right? You can use trigonometry and solve it. You can use many things and solve it, but let's solve it using algebra. 1 equal to root over of 1 minus x square, agreed? So 1 is equal to 4 minus x square. So x is equal to plus minus root 3. First, thank you for showing me the problem. Agreed? Mr. Conde, did you understand? So this is y equal to 1 line,
Yes.
right? So 2 is somewhere here. So this is root 3. I forgot. Sorry. So this would be turning out to be very simple. So x square 2 pi minus 1. So 3 root 3 0 to root 3 minus x cube by 3 2 pi, which is your root 3 will get cancelled, so root 3 2 root 3 into 2 pi. This is 4 pi root 3. Agreed? X cube is equal to x is equal to root 3 is 3 root 3. Okay? Are we okay? Good to go?
Yes, sir.
Okay. The last question before it will take quite a bit of time, so I kept a lot of time for it. So this question says it's a question about a question about area, right? It's a question about volume, but the thing is, it will give you an idea of a concept that we haven't discussed in integration yet. So what is that concept? It is known as the reduction formula. So this itself is a tough integral to do, and it's not possible to do it at one go directly without knowing what to do. So area bounded by rotating this function about the x-axis. So using the disk method, this is pi times f of x squared dx 1 to root 5. It's equal to volume, right? So you agree this is fx is greater than 0 for all x belongs to 1 to root 5, right? X square minus 1 is greater than 1, x square minus 1 is greater than 1, greater than 0, and x is greater than 0. So it's always greater than 0. So we can take the rotation about x-axis. So let's see what will it be. So it is pi x squared 1 minus, that's once we formulate this integral, this is the end of the problem related to volumes. And now it becomes actually a indefinite integral problem. You can't use definite integrals also. So do you know what to do in this type of equations when you have product of polynomials and this sort of a thing? This should ring some bells, because x square minus 1, if you substitute x as something, then ideally you should be able to find it and remove this root. The idea is to remove the root altogether. So I tried you can try integration by parts, that will not work. You may tell me make this x square minus 1 that I have been doing always, or try integration by part, but this will reduce. The one that you are trying to integrate will go on becoming smaller, so you can't integrate this function, you can only differentiate it. So it will become worse every time. Do you understand me, Mr. Pandey? Do you have any other ideas of by parts or something? So you had given me a few ideas. So you see, if x into, so this is not directly integrable. Do you agree? X square minus 1 is not integrable directly. It gives you a large formula. This is your formula. A square minus x square. So if you do this, again you will break up into integrals that are not again possible to do. So it's not there's only one way that I could figure out of doing this integral. So whenever you see x square minus 1 root over sort of a thing, what comes to your mind? So do you remember 1 plus tan square x, theta is equal to sec square theta, right? And sec square and tan theta are dd tan theta is equal to sec square theta. This is the trump card that we'll be using. So if you take t, or x is equal to sec theta, right? So this integral will become, your dx is sec theta tan theta d theta. Agreed? Took the derivative of both sides. Similar, yeah. Any question? So x square minus 1 is sec square theta minus 1, which is tan square theta or tan theta. Agreed? Everyone follows me up to this point, right? We'll just, after this it will become,
Okay.
Yes, sir.
yes, so after this it will become an integral of the of a trigonometric function. So you see x square is sec square theta. From this you get tan theta. From dx you get sec theta tan theta d theta, right? Pi into 1 to, so 1 to root 5 will change to, somebody will tell me now, I have been doing this for a long time, x and sec theta. So x is equal to 1, right? So theta will be, what will it be? X is 1 means 1 is equal to sec theta. If you take sec inverse of 1, that is 0, right? Cos 0 is 1. So sec 0 is also 1. I hope it is clear. Next, you have root 5, which is nothing but sec inverse root 5. Agreed?
Yes, sir.
Are the limits correct for everyone?
Yes, sir.
So 0 to sec inverse root 5. So now we'll forget about limits and all. forget about the limits of the integration for a time being. So this becomes x cube theta. It's correct, right? So x square was there. So this becomes x cube theta. So let's be right in the next line. 0 to sec inverse root 5 sec cube theta tan square theta d theta. Once instantly you get this, does this give you any idea? See, this is in any time you have a sec equation, it is a well-known reduction formula. So what do I mean by a reduction formula? So you see, tan square I will write in terms of sec square theta minus 1. Agreed? So I will get pi integral of 0 to sec inverse root 5 sec to the power 5 theta minus integral of 0 to sec inverse root 5 sec cube theta d theta. Is it okay? So do you see a form coming up? So I've replaced tan square theta as sec square theta minus 1. I've got sec cube theta and sec to the power 5 theta and sec to the power 3 theta. So there is a way to solve for this. So sec to the power m theta d theta. If I can find a general equation for sec to the power m theta d theta, will that be enough for us? Do you agree? And let us write Im as this.
Yes, sir.
Let us denote. Let's solve this. So this is a very important, this is known as reduction formula. And we always do it, but here you will get a iterative equation that will help you to solve a equation once you have an integral without using integration anymore. How will I do it? That's the question. So you will be breaking this up into two parts. What will you do? You will be breaking this up into sec square theta and sec to the power m minus, so m is greater than or equal to 2. So for m equal to 2, sec square theta d theta is tan theta, and m equal to 1, sec theta is log of sec theta plus tan theta, right? This is your general. We have written it down, so we have used these formulas extensively before. So 1 and 2 we know, these are the base cases. It's like a computer program. You write it a recursion and you have base cases at the end. This is your base case, and we will be using a general equation which will recurse over. So it's known as a recursion. So you'll see why is it known as a recursion. So I'll leave the calculation to you. Once you go back, you can do the calculation, but I'll do this now and leave it there. So let's see. So you all are integration by parts experts. You have told me last day, helped me a lot. Tell me which one will I take, which one will I integrate, which one will I differentiate. I've already given you the hint of breaking it up. Which one will I integrate, which one will I differentiate?
Sir, we will integrate sec square theta and differentiate sec m minus 2 theta.
So this is integrable. So this becomes tan theta, right? Tan theta sec to the power m minus 2 theta. Minus, so as Hedvi told me, so differentiation of sec to the power m minus 2 theta is equal to m minus 2 sec to the power m minus 3 theta into sec theta tan theta. Agreed? I differentiated sec to the power n first as x to the power n, then I differentiated sec theta, which becomes sec theta tan theta. Agreed?
Yes, sir.
So this becomes sec to the power m minus 2 theta into tan theta. Agreed? This is, I think, very clear.
Yes, sir. Yes, sir.
Okay. So this is m minus 2 integral of sec to the power m minus 2 theta. So sec square theta we have already integrated and got tan theta d theta. So this is what we have it now. So this is tan square theta, right? Not tan theta. So we have already, so let me write this. This is your derivative result. We have also an integration result from this. Agreed? So this is your formula is dd. So let's write it in the correct place. So you will have a tan theta somewhere here. Agreed? So your dd vx integral of ux dx whole dx. This is your second equation. So whichever you integrate it once, multiply with the differentiation, and then integrate it second time. So this becomes tan theta sec to the power m minus 2 theta minus m minus 2. This becomes sec tan square theta. So again, do you see the help that I am getting? So once I get tan square theta, I can write it again as sec square theta minus 1. Now comes the beauty of the reduction formula. How? As sec to the power m minus 2 theta d theta. Agreed? Everyone? This is equal to, this is nothing,
Yes, sir.
this is nothing but Im, right? So
Yes, sir.
so Im I got in terms of Im again. So if I take this to this side, so I get Im is equal to Im into m minus so m minus 2 plus 1 is m minus 1. This is equal to tan. So tan theta can be written as sine theta. This is the well known formula into sec theta, sec to the power m minus 2 theta minus, this is Im minus 2. You agree? Do you agree to this?
Yes.
Correct. So now Im is sine theta. This becomes sec to the power m minus 1 theta minus m minus 2 by m minus 1 Im minus 2. So now you will replace Im minus 2 as you require for any, you can give it to any computer program, it will be able to solve it. So this you will replace this as, what will you replace it as? You will replace this as sine theta again, considering m is greater than equal to 4 now, right? Because m minus 2 has to be greater than 2. Sine theta sec to the power m minus 3 theta minus m minus 2 by m minus 2 minus 1 Im minus 4. So you will reduce by 4 and so on. Did you find this technique elegant? You can have a lot of equations, a sine m to the power m, cos m to the power m. This can all be solved by a reduction formula. Okay? Does that solve all the questions? That solves all our questions for today. You can put those values and try and solve the final equation. So do you have a doubt? Anyone?
No, sir. Clear.
Okay. So the last thing that we will do is we will do a visualization of the plot that we had done, and then we'll stop. So the last thing is this is just give me 1 minute. Just give me a minute. So yeah, so I'll do the visualization of the equation that I told. So someone will have to tell me, I can't see the screen, so you'll have to tell me the equation that I told, that exponential. So I drew a frisbee sort of a thing. So if you can tell me what are the functions.
I think it was 6 e power minus x by 2.
Just a second, I'll just I'll see it, but let me share my screen first. Share screen. So I'm sharing the screen. Is it visible now? Is my screen visible, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So y, don't write y. If you write y, it will give you a 3D figure because it's a 3D figure anyways. So I'll just refresh this. Let's write f of x is equal to 6 x to the power of minus 2x, not x e to the power of minus 2x. So between x was between 0 and 1, right? So 0 and 1. So say this is your first function. You can see as we drew, exactly as we drew, 6 to the power e to e square, and you have g to the power gx as, what was the equation that we got? 8 minus 2 x minus 1 squared, right? See, I told you it has a maxima at 1. You can see now. Can you see?
Yes, sir.
So I will copy this again between. So we'll just see that if you can visualize, it becomes very simple. So this becomes two functions that we had, right? So now you see whatever we did was, I told you this will draw fast compared to this. Now I will just draw the surface of f comma 2 pi comma x-axis. This is you see the disk just like we had drawn, like a volcanic peak, right? And the volume has to be seen about the y-axis, right? Surface. Is it helpful? G of x and 2 pi x-axis. Did we rotate about x-axis or y-axis? This question? X-axis only now, yeah. X-axis. See, this is your volume. Can you see? Just like we had drawn. Can you see it? I can't hear any one of you because I can't see.
Yes, sir. Yes, sir. Brilliant.
So this was very interesting figure, so that's why I wanted to show it. See, this volume will be somewhere inside this, so it will look like a flying saucer or a frisbee. I hope that solves the questions for today. So next week what we'll do is, we'll be having the last session. We'll be discussing surface integrals and line integrals. That will be ending the series of tutorials that we did. So if you have any doubts, write to me over mail. So as I had replied to Mr. Pandey, I'll definitely try and do that. So if you don't have any doubts, let's stop for today and we'll meet next week, right?
Right, sir. Thank you and goodbye.
Yeah.
Okay, sir. Thank you.
Yeah.
Thank you, sir.
Yeah. See you. Bye.